everyone, and welcome back to my channel. And today we're going to have Graham's Law.
It was observed that if helium is substituted for nitrogen in the air in a closed room, one will feel much cooler than in a normal atmosphere. How can this phenomenon be explained? Well, let's have it this way. Food is metabolized inside the human body, accompanied by the production of heat energy. The body generates excess heat which is carried away to the surrounding air through collision of the air molecules with the skin. We feel comfortable when the rate at which our bodies generate excess heat is equal to the rate at which heat is removed by the air molecules. In a normal atmosphere, this happens about 26 degrees Celsius. Why does a helium-oxygen atmosphere feels much cooler than a normal atmosphere, that is nitrogen-oxygen mixture, at the same temperature? This phenomenon is answered by Graham's law, which states that the rate at which gases diffuse or mix, or effuse or move through small opening from a region of higher pressure to a region of lower pressure is inversely proportional to the square root of their densities or molecular masses.
Today we're going to have the application of Graham's Law formula. So our formula for Graham's Law is rate of diffusion of gas A over rate of diffusion of gas B is equal to the square root of density of gas B all over square root of density of gas A, or if you don't have the density, we can have the molecular weight or molecular mass. So we can say that rate of diffusion of gas A over rate of diffusion of gas B is also equal to the square root of molecular weight of gas B all over the square root of molecular weight of gas A. Get it? Alright, so let us have sample problem. How much faster does helium move than nitrogen gas? So that is what we're going to solve for this problem. So for the solution, let the lighter gas be helium, of course. That will be gas A, and the heavier gas is the nitrogen, and we're going to label it as gas B. So we're going to write R sub A as the rate of diffusion of helium because it is the lighter gas, and R sub B as the rate of diffusion of nitrogen. Alright, so to continue, M sub A will be the molecular weight of helium, and then M sub B will be the molecular weight of nitrogen. So our equation will be R sub A over R sub B is equals to square root of molecular weight of gas B all over the square root of molecular weight of gas A. So in our problem a while ago, so the lighter gas is helium, so we'll just write here rate of diffusion of helium all over the rate of diffusion of nitrogen is equal to the square root of molecular weight of nitrogen all over the molecular weight of helium. So you will see that nitrogen has subscript of 2 because it's diatom. So we will multiply 2 to the atomic weight of nitrogen, which is 14. That's why you have 28 grams per mole here. And then for helium, we have the atomic weight of 4 grams per mole, so that will be our denominator. Alright, so what you're gonna do is divide 28 by 4. Of course, you have to cancel out grams per mole and grams per mole, and then divide 28 by 4, so you will get square root of 7. And then you extract the square root of 7, that will give you 2.65. Therefore, the rate of diffusion of helium is 2.65 faster than the rate of diffusion of nitrogen.